All right, so what are the questions?
6 and 7.
I heard 5, 4, 2, 1 and 2. All right. Well, let's go and start from the beginning then. I want to make sure that you guys can get this. So let's take a look at number 1. So here they want me just to solve the system by graphing it. I'm going to graph the first equation. The first equation should start at -8 because that's my y-intercept, right? So got my first point, -8. My slope is a 1, which means 1 over 1. So I'm just going to go from there. I'm going to go up 1 and to the right 1 unit. So there's my first line. Second line starts at -2. So there's my point. And then it has a slope of -1. So down 1 to the right 1. I graph that. So there's my line. Hit save. It's going to check it. Boom. Okay. Now the next question says, what's the solution? Well, I'm looking for where the two lines are the same, which is where they cross each other. When the two lines cross each other, this exact point right there, the two lines are going to be the same. So I guess the question is, what coordinate is that? And that would be 1, 2, 3, comma, -5. So here's where I saw a lot of mistakes, not just here, but also on the test. People were just punching stuff in there, the numbers. But remember, this is an ordered pair. That means that you have to have parentheses, 3, comma, -5, close parenthesis. You can't just type in 3, comma, -5. That means nothing to the system because it's not mathematically correct. Okay, and it will get you on mathematical correctness. So there's that one. Questions? Not as bad as we thought. Okay, let's go to the next one. Same idea. Just graph the two, find where they cross, and you plug it back in. Do we want to do this one? All right, let's move on. Anybody need number 3? Same thing. This one's number 4. Okay. One thing you should know about these, x equals or y equals. Those are just going to be either a vertical line or a horizontal line. The way that I remember is that if I take a look at the first one, this says x equals -7. So if I go over to -7, here is -7. The question is, when does x equal -7? Actually, it always equals -7 because the equation says x equals -7. Pick another value for y. 3. Guess what x equals? 7. So -7, comma 3 is right there. There's another point. So do what you need to do to remember that x are vertical lines on that number. If x are vertical lines, then y equals are horizontal lines. In this case, at 2. So I'm going to go over to 2. And does it matter where I put the other point? It doesn't. You can put it wherever you want. I'm just going to go there.
No, you did.
Oh, yes, I did. Save, and I'm done. Now, this one's actually pretty easy to find the intersection because it is simply x, comma, y. So in this case, parenthesis, -7, comma, 2, close parenthesis, done. Math. Other questions? That was 4. Do we need 5? Yeah? Okay, here's 5. Solve the system by graphing. Same idea, except these are in standard form. You're going to want to switch them over to slope-intercept form if you want to. Looking at the top equation, I'm actually going to use my 2-intercept method because I can see that 4 is divisible by 2 and it's divisible by 1. Does that make sense? So here's what I'm doing. First, if I make x 0, can you guys see that okay? If I make x 0, what would the value of y be? 4. And if I make the y 0, what would the value of x be? 2. So I'm going to graph those. That's one of my lines right there. So I'm going to grab my line tool here. And I'm going to go to 0. There's 0, 4 is here, if I did that correctly. And then 2, 0. There's one line. Okay, let me go back over here. I don't know if I can type these in by halves and stuff. So I'm going to switch this line, the second one, to be in slope-intercept form. it reads negative x minus 2y is 1. I'm going to start by moving this over. That is a negative 2y equals, I'm still going to get halves, aren't I? So let's see, does this have halves on it? Yes, it does. Okay, that wasn't a problem at all. My bad. So if I make, I'll use red this time. If I make x 0, then y would be a negative 1/2. And if I make y 0, x would simply be a negative 1. So I'm going to graph those 2 points. So 0, negative 1/2 is right here. And negative 1, 0, sorry, negative 1, 0 is there. So there's my two lines. I'm going to check that real quick. Might have made a mistake. Nope, we're good. Now the question is, where's the solution? Let me clear the ink. The solution seems to be at 3 comma negative 2. So 3 comma negative 2. Math. Okay? This one you really had to be careful with because of the halves. I know that I found myself counting each block as 1 unit, but it really wasn't. Okay? What else?
6 and 7.
6 and 7, just keep going. Okay, so I'm going to make this a little bigger so we can read this together. Oh, that's not the right button. Okay. A store sells small notebooks for $8 and large notebooks for $16, right? Always start with the first sentence, try to make some sense of it. So I know that a small notebook cost me $8, a large notebook cost me $16. Okay? Now, it says that I spent $72, didn't I? Or that's how much I have to spend? So watch this. A small notebook is $8. That's 8S. Plus, if I spend $16 for a big notebook, or a large notebook in this case, how much money? Because this is $8, $16. How many dollars do I have altogether for that? $72. Questions on that? My equation is all about money, isn't it? $8 for a small notebook, that'll give me how much I spent on small notebooks. $16 times the number of large notebooks, that'll give me how much I spent in large notebooks. And that should match my $72. The next part says, if a student buys 6 notebooks, how many notebooks did we buy? 6. What type of notebooks did we buy? We bought small notebooks and large notebooks. And the small notebooks plus the large notebooks totaled how many? There's my system. There's my system. So now I can go ahead and solve for either one of those. Now, if you want to switch these to read x and y, that's okay. You can call this 8x plus 16y is 72, and x plus y is 6. Just know that x represents a small notebook, and y represents a large notebook. So at this point, you can take those two, you can graph them, and you can find their point, or point of intersection. Make sense? Was that the hard part? Switching it over to this? Do I need to finish this for anybody? Okay, it's just more of what we did before. Okay, I'm going to clear this up. We need 7, right? All right, let me clear this up. All right, 7 is just throwing the stuff into a calculator. I do want to show you this, and you're going to want to take some notes. If we do let you use Desmos, you're going to have to be able to figure it out on your own. Desmos.com, calculator. Okay? Oh no, I don't want to show you mine. I want to show you the clean version. Because this is where you guys have to go. I'll get rid of it. So this is how Desmos starts. You're going to go to Start Graphing. Okay? Now, in here, you're going to go to the little plus symbol, add an item, and we're going to add a table. We're going to have that down? Okay? And then we're just going to type in our data in there. So let me grab some of that data, that data. Hey, how come I didn't know? Oh, I opened a new page, huh? I got 2 of these. Let me do something like this. Okay? So if you put in, I don't know if you would want to do 1970, but maybe start that as your 0. Then we're going by 5s, right?
Yeah.
So I'll be 0, 5, 10, 15, 20, 20. Where are we at? We're at 90. So we need to go 25, 30. 25, 30. And then we're going to come back up here. And then we've got to punch in the value. So 65.8, 67.6, 68.6, 69.9. There it is. And then I need 70.6, 71 point, what is it, 4? And 73.2. Okay. So, there's my data. I need to get the equation of a line, don't I? So, here's what we're going to do. We're going to go ahead and click New here. And what we're going to do is we're going to type in a model. Right then? We're going to go with y sub 1, because it's y equals mx plus b, right? So y sub 1, you guys see subscript somewhere? y1, there it is. So you just type y and 1. It'll give you y sub 1. Normally we would hit equals, right? But because we're doing linear regression, it's not really exactly those points. So we're going to use a button called the tilde. Have you guys seen that button? It's a little wavy line. It's the one in the most upper right-hand corner. Looks like that. It's like what's above my enya. It's a little wavy line. Shift, and that'll give you that. Then we're going to go m x1 plus b. Y equals mx plus b. Look at that. So what it's doing, it's grabbing all the y ones from here. We're putting slope in, and then it's grabbing all the x ones from here, and then plus b, and it's going to spit out all of your linear regression. The line, oh, where'd the line go? Wasn't it there a minute ago?
Until you add plus b.
Plus b, plus b. We still needed those. Otherwise, it won't do the regression for us. Oh, and I know why it's not there. When we added plus b, what happened to the whole line? It all moved up because these points are so high over at 0. Yeah, so if you want to just, so you get to 60, let's go minus instead. See, there's our line. So now what you need to do for the next one, we're going to, oh, where'd it go? We're going to insert another table. You would put your new data in there. Notice that this is x2 and y2 now. So when you do your y equals, it should say y2 approximately and x2 plus b. It'll spit out the new regression line and another line here, and then you can find where they intersect each other. Are we cool with that? Yes, it is time consuming. But that's the hard part because all the answers given to you at that point. All right? Anybody need anything after 7? We're good? Anything after 7? Going once, going twice? All right, close those laptops. 10. Solve the system by graphing, tell what the solution is. Okay, so here, let's see here, can we do, y equals negative 2x plus 2 on the top one. And then we've got, this might take me a couple steps. So I've got 3y is negative 6x plus 15. When I divide by 3, I'm going to get y equals negative 2x plus 5. So this is what I'm looking at. this is what I'm looking at. And of course you know how to graph them now, right? So what you want to know is what type of system it is, which is one solution, two solutions, or no solutions. The first thing that I always check is slope. Are the slopes different or are they the same? If they're different, you'll get one solution. But these are not different, are they? They're the same. So now I have two options. Either they're going to have no solutions or infinitely many solutions. And that comes down to the y-intercept. If the y-intercept is the same, then you have infinitely many solutions. So let me make a little slide for you here. If m is different, you're going to get one solution. Should I make a flow chart? Let's see here. Let's start with m. Different, one solution. Same. You're going to have to check b. Is it the same or is it different? If it's the same, you have infinite solutions. If they're different, you'll have no solutions. Ooh. So in this case, we have the same slopes, but you had different y-intercepts, which means that the lines are parallel, and therefore have no solutions. Cool? All right. Any other one? Same. Same. Can you tell the difference between these three? Can you get them? Dependent, inconsistent, dependent. Here, let's go back to this flow chart. If you have one solution, what was the one solution, guys? Dependent or independent? Independent. If it had the infinite solutions, it's called dependent. And if there's no solutions, inconsistent. Okay? All right. What time's the bell ring? 11? 11:15?
10:15.
Oh, 10:15. Oh, good. All right. All right, let's get to it. Close those laptops, please. You guys can finish your homework tonight. Cell phones are put away. No earbuds in your ears. Earbuds. I said it right? I always say earphones. Headphones or earphones. We used it when I was in school. It was all headphones. I said headbuds yesterday. All right. So today, yesterday it was all about graphing or looking at the table, but we just did graphing mostly. If you do have a table, all you're really looking for is where the coordinates are the same. So now we're going to do algebraically. You should have already done this, so it is a review. We're doing both substitution and elimination. Devin? That's going to just make you go to sleep here. Pick your head up. Get straight. Okay. Solve by substitution. Here's a system. At the beginning of the first question, I said when we're solving a system, we're really looking for where the two lines are the same. That make sense? When we're using the substitution method, what we want to do is we want to take one equation, what its value is, and we're going to substitute it into the other. So if you want to use substitution, you're going to have to learn to kind of look at those and analyze guys equations. Let me make this a little bit bigger for you. Now, personally, I like elimination. I would just go with elimination. But here's what's going to happen. Do you guys notice that the bottom one would be really easy to convert into y equals negative 2x plus 10? Yeah. That's pretty easy, isn't it? I can see that. That means it's a good candidate for using substitution. Now, what that means is that I'm going to take this equation and I'm going to plug it into the other one. The other equation reads 3x plus 4y equals 12, right? Question. What letter is this?
Z.
It's not a funny question. We don't have time to be funny. What letter is that? What is the value of y? What does y equal? We're going to trade it. 3x plus 4. Guess what I'm going to put in there?
2x.
Exactly. Negative 2x plus 10. So now I'm going to solve it. 3x. Which property should I use here? Distributive. Negative 8x plus 40 is 12. Questions on this step here? You shouldn't be writing it down. You should be watching me do it. You can copy after. Or you're going to miss a step. And then you're going to be confused again. Are we good here? You blinked, so we're good? All right. I'm just going to clean this up. Combine these two. That is a negative 5x plus 40 is 12. I just combine like terms. I'm going to kick over the 40. Go ahead.
No, when you subtract 40.
Right. That's my next step. Subtract the 40 to both sides. Negative 5x is equal to, what is it?
32.
Oh, I had to make a mistake. Where did I make my mistake? Yeah, it should still not be that. Let me see here. Let me go back to the top. I switched over the 2x, right? That's okay. 3x plus 4y is 12. I plugged in negative 2x plus 10, negative 8. No, that's right. Why is it gross? What is this? Negative 20. Here's what I mean. I have to divide by negative 5, right? So that means that x has a value of 5 3/5. If you're learning how to substitute, we shouldn't have something like that. It's not very nice of them for us to do something like that. But it is what it is.
Was that one of the questions, or did you make that up? Oh, question.
Okay. Now, it's not a problem. We've got our value. Anybody want to see it as, leave it as improper? Is that easier for you guys? That's cool. That doesn't bother me at all. It's going to be a positive though, right? Positive 28 fifths.
Why didn't you just make nothing?
Another what?
Why didn't you just write it?
It's whatever you want. I'm going to leave it as 28 fifths. Guess what? I know the value of x. Now I just need to get y. That's okay though, because I know that y equals, what does y equal? Y equals negative 2 times x plus 10. And what was x?
28 over 5.
28 over 5? So what's 2 28ths?
Was it negative?
No. This
Yeah.
is positive. So negative 56 over 5 plus 10. Ooh, I'm going to have to put a denominator on this. What is that? This is going to end up being 5, and then that's going to be a 5, right? Because I got to make it 5 times bigger. So 50 minus 6, that's going to be negative 6 fifths. So here's y. Okay? Yeah, substitution is not my favorite. It gets kind of messy. Once we show you elimination, how many people hate elimination? Some people do it. You will love it. Elimination is so easy. We love it long time. Okay. Hold on. Let me go ahead and make this, put this so you guys can copy it. I should really be doing one thing right now before I solidify my response. And what is that? checking it. Which equation should I use to check it? Both. Both. If the solution does not work for both equations, you have not solved the system. You should always check it for both. God knows that I always checked one, and it wouldn't work for the other one, and I lost points. It will happen. Not really happy with that question. And just a heads up, your answer should always be in a coordinate, which becomes, in this case, 28/5, comma, -6/5. We have that copied, okay? You remind me of a comedian.
My whole life, I should.
He was talking about in high school, he did that he was writing a paper, and his teacher said, it's really nice, but you should rewrite it. He's like, nah, I'll just make a copy. I'll just Xerox it. Like, okay. It was funny. The way he said it was just hilarious. He was talking about, you have some mistakes. You should rewrite it. It's like, well, why would I rewrite it with mistakes? Do you want me to correct it? So it was like, it was funny. He had a streak of jokes going. Can I change the slide? No. Alka-Seltzer is always good. Drink a Sprite. Una 7. 7 Up.
I hate everything except for water. I hate everything except for Pepsi and coffee. I hate fruit punch.
So you hate us? Oh,
No,
wow.
I'm just kidding. Well,
We're good now? Okay. Let's try that substitution one more time. I promise you're going to love elimination, but I will show you that substitution one more time. In this case, if I did want to substitute, which one would I change? Yeah, the first one. What would I do? Say that is -3y plus 5?
No, it would be -3y equals -5 plus. You wouldn't change the y?
Why is that? Why would you do that?
Because y would be first.
But it's easier to just kick this over, and now I know what x equals. You see that?
I think it's just your preference. Yeah, I wouldn't.
Well, that's the thing. It's not about preference. It's what's going to get me there faster without mistakes. Isn't it easier to just kick over to 3y? Yeah, so don't make this harder for yourself. So here now we can rewrite this. -2 times x minus 4y is -5. What goes in for x? -3y plus 5. So I've got 6y minus 10, I believe. Double check. Minus 4y is -5. Combine my like terms. That means this one and this one. So 2y minus 10 is -5. What should I do at this point? Yeah. Oh, they are going to give us fractions the whole time. So 2y is 5. Divide both sides by 2.
Is it always going to be?
There's my y.
Why is it? Yeah. Can't beat that.
Now how do I get my x? It's up there, isn't it?
Plug in that y.
Exactly.
For a reason.
X equals, what was it? Negative 3y,
Plus 5.
thanks, plus 5. So x is equal to negative 3 times 5 thirds. Oh, I like that. That was good.
It's 2.
Because that's going to give
5
you...
over 2.
Aw, sad face. Swear to God, I looked at it and I wanted to see a 3 and I saw a 3.
Switch it up.
But it wasn't.
But it wasn't. So, negative 15 halves plus... Let's see here. I want that to be a 2 so it becomes a 10, right?
Where does the 3 go then? It just goes
3
to
times
the
5.
top. It doesn't go to the bottom?
No, never.
Oh, okay.
Because that's really 3 over 1, isn't it?
Oh, yeah.
So 3 times 5, 1 times 2. So now I've got this, which means x is negative... Oh, cool. Negative 5 halves again. So 5 halves, comma, negative 5 halves, comma, 5 halves is the solution. Questions on that? Here's the whole screen. What's up? This 5 has a denominator of 1, right? I want it to be 2, which means I doubled it, so I got to double the top. Elimination is next. It is my most favorite.
Also, we're eliminating people.
Pew, 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 pew. Yes? I'll do substitution. Okay, take a look at elimination. See if you like that better. And then if you do, make that one your choice. Okay? Because you're going to love it. Substitution gets really weird for me. I don't know, like you. Okay? But if you don't and you still want to do it, then you can do some more tricks. Alright. What's up? I just answered that question. Remember the 5? What's the denominator? I want it to be a 2. I doubled the denominator, so I have to double the numerator. You're going to want to watch this next one. You're going to love it. It's going to make you feel better. You'll be like, I've got math energy now.
So does that mean you're gonna car?
Yes. Without math, there is no car. We're good? Legos are math. Someone had to sit there and think about how one Lego would fit onto the other and hold solidly. Now it's more science. Well, without math, there's no science, so.
Why don't you just marry Matt then? She said no. He tried.
I'm not going to respond to that. I'll respond to that later. We're good now. Alright. Okay. Solving by elimination. I know some of you love substitution. Substitution is just fine when you can wrap your mind around how it works. But elimination can be so much faster. The objective of elimination is to eliminate one of the 2 letters to start. Okay? So, the easiest way is by being able to make one the opposite of the other. Does that make sense? So, like if I have a 4, how do I get rid of a 4? By adding a negative 4. 4 minus 4 makes 0. Does anyone understand that idea? Super easy idea, isn't it? We're going to take that idea and we're going to put it into play when we do this problem. So here's one, for example, and I love this one to start because, check it out. What's already opposite?
The 4 and negative 4.
Guess what? I'm going to add these 2 equations. That's gone. 2 plus 3 makes 5y. 9 plus 16 makes 25. Divide both sides by 5. Guess what the value of y is? Halfway done. Halfway done. What happened? Did you blink?
Yeah, I did.
I blinked a lot.
I understand.
Do you understand what I just did? Does anybody need me to repeat what I just did? Look at those smiles. I like this. All we have to do now is get x. Pick one of the 2. Which one would you use? I'll use the top one too. That's my bet. So watch. 4x plus 2 times 5 is 9. 4x plus 10 is 9. Minus 10 minus 10. They're going to make us have a fraction here. Oops, I forgot my
Why
x.
do they like fractions?
Because you guys are scared of them. And you need to not be scared of them.
I'm not scared of them, I just dislike
That becomes 1, so there's my x value. Solution here, negative 1/4, comma 5. Math. Oh, I plugged my answer into one of those. Yeah, we picked the top one. But you can use any one you want. You should get the same thing. You want to do it the second one? Let me... Second one, I'll just use black. So negative 4x plus 3 times 5 is 16. Negative 4x plus 15 is 16. Take away 15 of both sides. Negative 4x is 1. Divide by a negative 4. X is negative 1/4. Isn't that cool? Math! You can't mess it up.
I find a way to.
I find a way.
There's always a way. Yeah, right. You see my test scores. How difficult that was.
Just like that? A lot cleaner, isn't it? Okay? Not saying substitution is bad. I'm just saying elimination is cooler. Stop smelling desks. There's chemicals on there. The chemicals are going to get you. I gotta make that cleaner. That looks really sloppy. Not bad. You can follow that okay? I feel like it is though, but. Ooh, I like those shoes. Can I change the slide? On to the next one. Okay, no objections. Here we go. Here's another system. Here, let's have you do this one. Which ones? Well, not X, but what about the, get rid of those 8s. Love, peace, and hair grease. I'll be 5,000.
It's 3x equals.
Right?
X is equals 4.
What do you do with that? Plug it in for X. Which one? Whichever one. Doesn't matter. Whichever one you think is easier for you. You like that? Oh, you're talking about the other part now? Let's see here. So we've got 20 minus 8y is 20. So yeah, this will cancel with that, which means y has to be 0. Right? Here, think about that. I did that too fast, didn't I? My bad. So 5 times 4 minus, 8y is 20, correct? So this is really 20 minus 8y is 20. If I take 20 from both sides, this is gone. I'm left with negative 8y equals how much?
0.
So what did y have to be in order for me to get 0? 8 times something gives me 0. Now if you want to divide, you can. What is 0 of negative 8s? Still 0, even on a bad day. Solution, 4 comma 0. Yes? Where did I get 3x equals 12? We added the two equations up here. See how those cancel? So what's 5x minus 2x? And then 20 minus 8? Boom. Nice? You like it. How do you feel about elimination now? I eliminate all day. I'm going to show you some tricks because obviously they can't all be that easy, right? Okay, so I'm going to show you on the next problems. Can I switch the slide now?
Yeah.
Okay, here we go. Sometimes the problems are not going to be handed to us like the last two were. So, I know, how dare you? So what we're going to do is we're going to solve by what's called an equivalent system. It's called an equivalent system. And if you'll just watch me, I will show you what I mean. Here's typically what you'll get. Something that's not really nice. Put those pencils down, just watch for now. All eyes up here, please. Obviously, I can't just add and something goes away, correct? So I have to stop and think. I gotta make a choice. What do I want to get rid of? Truly, it doesn't matter. It doesn't matter.
X's because it's little.
Yes, that would be my thought too. Oh, and when I look at x's, the numbers are smaller. So here's what I'm going to do. You guys remember when we used to find the LCD? The least common denominator bit? Okay? If you think about it this way, what is the LCD for 2 and 3? 6, right? So here's what my objective is. I want this to become 6x. And of course for the 3, I'm going to want it to be the opposite. So I want that to be a, and I'll use another color. I want it to be a negative 6x because when I add those, guess what happens? They cancel, right? So here's the question. What do I need to multiply this whole equation by for the first number to become a 6x? 3. So I have to do it to the whole thing. So 3 times 7 is 21y and 12. Then on the bottom, what do I multiply by? Negative 2. So do it to everything else. That would give me a negative 10y and positive 10. So when I solve this system, aka an equivalent system, I'll get the answers to that system. Watch. What happens? Exactly what we wanted. This becomes 11. This becomes 22, which means y was 2. How do I get x? Go up to the top. I want to pick an easy one. 2x plus 7 times 2 is 14. 2x plus 14 is 14. Oh, JK, smiley face. LOL. Sorry. 4. Take 14 away. That means that I've got negative 10. Divide by 2. X is a negative 5. Therefore, my solution, negative 5, comma 2. How do you like them apples? Sour. When we lived in California on our way to elementary school, this guy had a sour apple tree, and it would hang like towards the sidewalk. And I remember one day we got brave enough to grab a few, but they were hot. And me, my brother, my friends, we all got diarrhea that day. Because we were having hot sour apples. It was like, yeah, it was bad.
They ain't eating apples again.
That's it. And our tree. They were on the sidewalk side, but I know. But we wanted to try them. Yeah, they were warm, so it was. You ever have a warm apple? Yeah, they're not that great. And then with the bitterness of it, it was kind of weird. Yeah. I know.
One bite.
Because I was hungry. You know what that's like when you're hungry. No matter what it tastes like. Is it edible? I'm not gonna die, right?
Well, you almost do.
I know.
I guess so.
I know, like, it was bread and meat.
Yeah, but I mean, when we had it, it wasn't whole wheat bread.
Disgusting.
I love whole wheat. I like it when it has the grains in it. You ever have that? Like the whole grain stuff? You can feel it. Oh, delicioso. Toasted. Yum, yum, yum. Go for it. We're good? Alright. How are we on time? I got 7 minutes. I can do one more. Here we go. If you don't want to write this down, just sit there quietly and watch me do it. Verify that the steps that I'm taking make sense to you. In this case, what would you go after?
The X.
Does it matter? Not really. But X, since that came up first, what do I want the X's to become? 15x and negative 15x. What am I multiplying on the top equation? 5. So that becomes 15. I'm going to get plus, what is that, 35? 35y, 50 plus 75. And then what am I multiplying the bottom equation by? Beautiful. You guys are amazing. 6y, 12. Look at that. Bye-bye. 35 minus 6 is 29.
Yeah.
And 87. Divide by 29 to both sides. That's 1. Can that be simplified? 15. No. No. So leave it that way. It's not nice, but. And here's what I did. 8 plus. Go ahead.
It's 3.
It divides evenly? Thanks, James. So y is 3. I was way wrong. I was trying to simplify it by dividing both by 3. Questions there? What are we going to do for x? Plug y into which one? Either one. Either one. So I'm going to go with the top one. No, bottom one. Bottom one. 5x plus 6 is a negative 4. Excuse me. Minus 6 minus 6, that's gone. 5x is a negative 10. X is negative 2. There you go. Yeah, because when you divide by 5, this is a negative 10. This is negative 10. Divide by 5, negative 2. Are you okay with this equation?
I get how you got 15 because 3 times 5 is 15, but
So 5 times 7 is,
35, yeah.
5 times 15 is, so you're okay with these two equations?
I don't get how you got negative 3.
How does this become a negative 15? it was this, what do I multiply by to get negative 15? Okay? Because I want them to be opposites, remember? So that's why I chose negative 3.